Good morning, ladies and gentlemen. Welcome to Swine Day. My name is Ken Odie. I'm the head of the Department of Animal Sciences and Industry, and it's my pleasure this morning on behalf of the Department of Animal Sciences and Industry, our Colleges of Agriculture, College of Veterinary Medicine, K-State Research and Extension, and Kansas State University to invite you here. We're very pleased that you've chosen to join us for this event in this particular program. We're quite sure that you will get a worthwhile experience and a lot of good information here today. I want to start out my comments this morning and just tell you that this is an exciting week at Kansas State University. On Tuesday of this week, we had a new president named for the institution. General Richard Myers, who was our interim president, was named as the Mike, is it the 14th president of Kansas State University? And that's a big deal. And I want to make a few comments on that because obviously General Myers doesn't come from a academic background, but he does come from a military background. He was chairman of the Joint Chiefs of Staff in the Bush administration, a four-star general. And obviously he has a tremendous amount of experience and leadership. And I personally think that that choice was a very good choice. I think what we really need in this university and many other universities right now is credibility, and credibility with the public, credibility with the legislature, and I think General Myers can be a very, very positive force for Kansas State University and probably for higher education as well. So my own view is this was a good decision by the Board of Regents here in the state of Kansas, and will be a good decision for Kansas State University. So I wanted to start that out because in a sense there will be a lot of things coming about here in the next few months, and we're really excited about what's ahead of us in the future. Just a few comments on our department. Our department continues to do well, and we have many, many ways of looking at that, but one of the ways we look at that is our undergraduate enrollment. We now have, this fall, our official undergraduate enrollment was 1,234 students. I think that's our second largest enrollment ever, but we have a lot of students who want to come to Kansas State University. About a third of those come from out of state, and I know many of you come from other states as well, but we have a lot of students here who pick Kansas State because we think, and ultimately they decide, that it's a good place for them to complete an undergraduate education here at K-State, and for us especially in animal science. So we're always excited about that. We've got outstanding research programs, and you're going to see the results of one of those. Much of the work going on in our swine program today, but we're doing well in that arena. And if you listen to General Myers, he's committed to continuing to grow the research agenda here at Kansas State University, and so we're again enthused about that. The other comment that I want to make is this is a particularly tough time in production agriculture. It's rare in production agriculture that we get low livestock prices and we get low crop prices simultaneously, but this particular ag economy is putting a lot of strain on a lot of people, and it probably will for a few years. And I think it's really important for an organization like ours to be what I like to call fully engaged. And fully engaged means that we are not sitting in the ivory tower just doing whatever we think, but we're doing what our industry people value. And the word I like to use for that is relevance. We continually need to be examining our relevance to the people that we're actually here to serve. And I think we do that quite well, but I'm sure we can always do that better as well. And that leads me into just a few comments about Swine Day and our swine program. The swine team here at Kansas State is internationally recognized. I would actually argue that the swine team at Kansas State really has no peers when it comes to the number and breadth and size of the work that they're actually doing and recognition internationally. The Swine Day program for last year was downloaded in 112 different countries. So if you think about the global impact of the information that's being generated and delivered here by the swine team at K-State, it's pretty darn impressive. So I'm really, really proud to be able to introduce you to the swine team, and these folks need no introduction. Many of them you know and you've worked with for many, many years. But I want to start out this morning by introducing Dr. Jason Woodworth. He joined us a few years back, doing an outstanding job, and Jason is going to start the program. How about a hand for our entire swine team before we start the day?
Thanks, Ken. You know, normally the kickoff of these events, Ken, is supposed to be people telling jokes to increase the activity in the crowd. But I'm disappointed you didn't have a joke for us there, Ken. But I want to take the opportunity, or maybe you do. Okay. He's leaving. But you know, first off, I really want to take the opportunity to welcome everybody to the 2016 Kansas State University Swine Day. It's a pleasure for us to receive everybody here today, and really want to take the first chance to say thank you for making the choice to be here with us. You know, it's not many days when you get 80-degree days in November in Kansas, and so I know there's a lot of farming that could be going on right now. We really appreciate you choosing to be here with us today. And so before we get kicked off too much, just a couple housekeeping items. Number one, I want to thank you in advance for turning off your cell phones or muting the ringers just right there so everybody can enjoy the rest of the presentation. Number two, if you've looked at the agenda, this first two and a half hours is going to be a lot of information. We're going to flow through pretty quickly. And so what we're going to ask is that we just wait and hold all the questions until after we're finished with the presentations. We might have some times right afterwards. Otherwise, we'll all be available during lunch and during the afternoon session that we can chat and interact with you at that point. And so with that said, let's get this rolled on. And so, like I mentioned, a lot of information coming here today to you. And so our 2016 Swine Day report has 42 different papers in it that encompass 47 experiments, and we touched almost 25,000 pigs through all of these experiments. And so, again, we'll be rolling fast, a lot of information thrown at you. The good thing, I think everybody has the booklets that you received at registration. In those booklets has the abstracts and the summaries from each of the trials, but also don't forget the best resources. Our website, ksuswine.org, has the full reports for all of the trials that we'll be talking about here today. Also lots of other tools and information that some of the other presenters will be highlighting as we go through today. And so, also what you'll notice with all the presentations here, all the faculty, we're going to use the word we a lot during our presentations, and that we is code word for graduate students. And so really it's the graduate students that have done the brunt of a lot of this work, and I'd like to take a moment to have all the graduate students stand up and be recognized for all the activities that they've done here today and making this event possible. Excellent. Great job. So it's a nice opportunity to be up here because they're the ones that make our jobs easy. They're the ones that allow us to be able to take the opportunity here and share with what we're doing. And it's easy to understand how they can be recognized by the productivity that they have, but also the amount of achievements, the amount of other accomplishments that they've made is significant for the program. I just want to take a minute to talk about some of the awards and the achievements they've had throughout the year. So when we have our Midwest Animal Science meetings, are our core meetings where we go and present abstracts and present information to the scientific community, and had a great showing for some of the competitions we had there this year. Carini won the oral undergraduate research presentation right there, which was a tremendous accomplishment for someone who came in as an undergrad for a year project with us from Brazil. And we're really fortunate she was able to and chose to come back for her degrees here at K-State as well. Dr. John DeYoung and Josh Floor won the ASAS Young Scholars Awards. Annie Clark had the first place master's oral presentation, as well as a K-State Donahue Graduate Scholarship. Lori Thomas won the first place master's posters presentation, also the Pinnacle Award from International Ingredients, and then finally a Feed Energy Scholarship. So Lori, you really cleaned up this past year, and so we'll be looking forward to that and continue. Jordan Gephardt won the first place for the PhD poster presentation at the Midwest Animal Science Awards. Lonnie Schumacher also won the National Pork Board Innovation Abstract at the Midwest Animal Science meetings. Corey Carpenter was a recipient of the Presidential Doctoral Scholarship as well as another Feed Energy Scholarship. Roger Cochran also recipient of a Presidential Doctoral Scholarship. And Arkin Wu was the first recipient of the Bob and Karen Toller Graduate Student Swine Nutrition Scholarship. And you might recognize that name, Bob Toller. He's a past graduate student with our program. He's on staff up at South Dakota State University. And we're really fortunate that he saw an opportunity to help promote the swine industry here in Kansas and to continue to help grow our graduate student program here at K-State. So Mariana also won an award at the Lehman Conference this summer with the Best Paper Award there. But then at Midwest Animal Science, one of our alumni, Casey Neal, was the Midwest Early Career Agribusiness Award. So definitely you can see through our discussions here today, a lot of productivity, but also a lot of achievements, a lot of accomplishments by this fantastic group of graduate students that we have. So we're going to kick off today talking about the feed mill biosecurity, and what I'm going to do is hand this over to Cassie Jones to take the lead on some of this early presentations. And just for a way of introduction, I'm sure a lot of you are familiar with Cassie. She's been here on the docket for the last couple years, speaking at Swine Day, and we've, for the last 4 years, she's been part of the grain science program at K-State. We've been really fortunate that there was an opportunity to bring her over into the animal science department. So this fall, she's been on staff with us in animal science and continues to support the swine program as well as the graduate student program, or the grain science program. And we'll let Cassie start talking a little bit about feed mill biosecurity.
All right, thank you. And this is one that we, again, have a team of people within a team of people working on feed mill biosecurity. And so there's a number of us from the vet school here at K-State, Dr. Stark, and others in the feed science program, and then the swine nutrition team, my role in it. And then we also have kind of crossed the breadth of the university walls as well, and we work extensively with the Iowa State University and their diagnostic lab as well. And so one of the questions that we get asked most frequently is there a value on some of these interventions or some of these pieces? And one of my responses is always, is there a value on preventing some type of outbreak through a feed-borne pathogen, right? You would all be familiar with this path, and so it's, or this slide, and you know, the real question is there a value for safe feed? There's certainly a cost for unsafe feed, and a lot of the focus today is going to be on nutritional and wholesomeness of that feed, but we also have an expectation that whenever we're manufacturing feed and producing it, that it's always safe in front of the animal as well. And we're familiar with this slide. This is PED over the years and a lot of the knowledge that we've gained since that ugly winter of 2013 into the spring of 2014. And we have little blurbs every winter, right? But we've been really fortunate that our industry knowledge has really been advanced, and a lot of the practices you are employing every day has really helped keep these at a minimum over time. We want to remember this as we go into winter months, and even though we have 80 degrees today, that we certainly have had swine days, which are much colder, and as we move into winter to keep this in mind, and that's really setting the stage for what is feed mill biosecurity, what are some of these considerations that we need to be paying attention to, because we know that the titers and the infectivity and some of those pieces of our gilt herd and our sow herd is diminishing, and so what are some things that we can continue to remain below this epidemic threshold, both of PEDV, but also of other potentially pathogenic diseases that could be transmitted through feed. The other one that I like to really talk through, producers, is one that's not directly related to feed safety, but there's a lot of things that we can do in a mill to improve the bottom dollar. And so this is actually a slide that was provided to me by a mill manager from an integrated poultry facility, and his facility that he walked into previously wasn't very well maintained. They had been really chasing a target adjusted feed conversion on the poultry side with different formula adjustments and different pieces, and he accepted the challenge to go into this mill, and his date was about right here, and this is going to be weekly or closeout periods over different broilers. And so you can see that certainly was not just one individual coming in to make some of these changes, but he was able to make a very substantial shift in the culture of the feed mill. And that culture shift, which certainly did include helping others get on track with both feed mill biosecurity, but also really paying attention to things like crumble quality in this case, and assurance, a lot of the quality assurance things that Dr. Stark visits with producers closely about, but also what can we do from an ingredient supplier side if we are not having great relationships with them. But I think it's important to understand that safe feed and wholesome feed, that part in the feed mill is something that we can't forget about as well, because we can spend a lot of time as nutritionists trying to chase a feed conversion side when some management things that we can be employing can really help us improve our feed conversion and our bottom dollar on a system-wide purpose as well. So as we think about that, there's a couple resources that we've helped develop along the way that really help underscore kind of what our current thoughts are on feed mill biosecurity and feed processing expectations. One is a National Pork Board publication, The Role of PEDV in Feed, and it kind of outlines our current knowledge and understanding. And so I think it's important to read and continue to be diligent about some of those. We've been fortunate the last couple years that we have not had the spike above our epidemic threshold that we had that initial year. But I think another piece that I think is really valuable is we have a publication that is just recently published in the Journal of Swine Health and Production. That's kind of an outline about some of these feed mill biosecurity principles. And Jason and I are going to ping pong back and forth this morning just briefly to kind of talk through some of the pieces that we've learned along the way from a research perspective, and what are some things you could be employing that most of you are doing already on your farms and taking those principles into the mill itself. All right, so I like to talk about this from a three different step perspective, because if you think about biosecurity on your farms, you don't just have one step. You have multiple interventions, multiple stop points to prevent different hazards from being transmitted, entering your facilities, entering your barns, but also to prevent potential cross-contamination from one barn into another. And we have that same type of perspective on the feed mill if we think about it from that side. We have a lot of traffic through feed mills. They're very complicated systems, and sometimes that's difficult to control. And so we talk about it from a prevention perspective. What are some stop points that we can implement at the feed mill to prevent some of these hazards from entering at receiving by using sound receiving procedures, controlling dust, zoning personnel and where we allow them to go within the facility, and what can we be employing from a flushing and sequencing perspective beyond what we think about from medicated feeds, but in terms of high-risk diets versus low-risk diets. That said, that's probably not enough in many cases, especially for some of our high-risk mills. And so many individuals and many facilities have started to ask us about some of these interventions. Okay, we're going to try to put as many of those stopgaps in place as we can for this prevention, but many of our biosecurity plans on the farm have other interventions associated with them. And so that's where we've shown previously some of these point-in-time mitigation steps, and I'll talk about those in terms of what can we do with thermal processing, what can we do with some type of UV or irradiation associated with it for different ingredients, and then what are some of the chemical or chemical application principles that we could be doing to ensure that we don't have cross-contamination through feed as well. And then finally, one of the questions that we've been getting asked quite frequently lately in the past year is, what happens if these all fail and I have contaminated feed and a contaminated feed mill? And that's where we're looking at a post-vention perspective. What are some solutions that we can provide to facilities that they know that they have pathogens already established within the facility, whether it's Salmonella or PEDV? What are some things that we can employ to help decontaminate those facilities across the board? And so Jason's going to take the prevention category, and I'll turn it over to him.
Thanks, Cassie. As Cassie mentioned, the prevention part is something that we're all familiar with on our farms. So as Cassie mentioned right here, I mean, the prevention is something that we're very familiar with from our farms, just from the standpoint of shower in, shower out on the facility, a Danish bench type of a system. It's something that shouldn't be too foreign from us, but it's something that we don't really think that much about from a feed mill perspective. You know, here's a couple of pictures right here. Things as simple as just covering the incoming ingredient pits to prevent any sort of dirt or manure flowing in when a truck happens to drive through it is a good step to be able to employ. You know, also we see a lot of people starting to put basically a funnel over the pit so that when the trucks come in, they use the funnel to hopefully prevent any of the grain from going outside of it. You know, kudos to this farm right here, or the feed mill, for using this. Unfortunately, they're not really using it appropriately right there. And so the goal is to not have any of that grain on the outside of that funnel and be able to get it all in the pit. And so it's not only pretending to do the things right, but actually doing them right on a daily basis right there that will really make the big impacts when we start talking about prevention of contaminants in our feed. You know, one of the big things really we need to take a mindset of when we go into the feed mill is the traffic of people through the facilities. And so, I mean, ideally what we'd like to do is to keep all the truck drivers in the trucks, you know, not having them exit their trucks and enter and be able to walk through the farm or through the feed mill and have free access everywhere. At the very least, have them in specific zones where we consider that zone a dirty area, just like we do on a farm, so that there's no cross traffic through those zones. If people have to get out of trucks, move around, having boots, having booties, having some sort of PPE that helps prevent the contamination, the cross-contamination from one location to the other is definitely an ideal process. Now, the other thing that we'll talk a lot about today is dust control and dust mitigation, and just how significant dust is in the cross-contamination within a feed mill. And so here's a mill, Joel, that we were at that did an excellent job of installing a dust collector within their system. Unfortunately, what they chose to do was also have a drag screw right underneath it so they could add that dust back into the feed. Because, you know, we don't want to have any shrink when we're producing our feed, and so want to make sure we capture everything that we pay for and put it back in. But you'll see through the presentation here today, as well as some of the other discussions we've had, dust is a significant carrier, potential risk for cross-contamination, whether it be PED that we'll be talking about today, whether it be mycotoxins that everybody's talking about here this year as well too. And so if there's only one takeaway from today, make sure you go back to your feed mill, and if you're collecting dust, throw it in the dump, throw it in the trash can. Do not put it back into your feed, because that's a significant risk for cross-contamination. One of the studies that we looked at was determining whether sequencing has an impact on preventing cross-contamination. And so sequencing is really the planning of one batch of feed to the next and figuring out the progression of feed that's going to be manufactured in the facility. What we did right here, we designed a study where we had a negative batch of feed that we put through a mixer and a bucket elevator, very similar to a commercial feed mill. After that, we had a batch of feed that we contaminated with PED, and so it was PED positive, then followed that with 4 sequential batches of negative feed, just to determine how much cross-contamination, how much carryover of that PED we'll see in the subsequent batches. If you focus on the columns right here, the red columns represent feed that was collected from the mixer. The purple bar, or the columns right here, feed that was collected from the bucket elevator. So it shows different points of collecting feed. This is the amount of PED in this feed measured by cycle threshold, CT values. And remember, a higher cycle threshold means that there is less PED detected in the feed. So after the positive, after we put through positive PED feed, we clearly expected and we saw a high level of PED contamination in that feed, whether it be collected from the mixer or the bucket elevator, just as we'd expect. But then remember, we followed that with 4 other batches of initially PED negative. But that batch, whether we collected feed from the mixer or the bucket elevator, we still were able to pick up some contamination of PED in that subsequent batch of feed. So it showed that there was carryover of the PED into the subsequent batch. Even after in the second sequence of feed, we did not find any PED in the feed collected out of the mixer. However, we did observe that there was PED still present in the feed collected after the bucket elevator. And that's something that we really want to stress. If you've ever been into a feed mill, if you understand how a feed mill operates, the boot of a bucket elevator is something that is basically impossible to ever clean out. And so it's a significant source of recontamination from any sort of a previous batch into the subsequent batches. And so, again, when we took samples of the feed, we found contamination after the first sequence and after the second sequence in the bucket elevator. However, no feed from the mixer or the bucket elevator were deemed to have PED and the third or the fourth sequence of feed. However, let's look at the lines right here, though, and these are the environmental swabs. What we did is we went in with basically a giant Q-tip and swabbed the insides of the equipment to see if there was still PED on the surfaces of the equipment. This yellow line right here is a swab from inside the mixer. The maroon line right here is a swab from inside the bucket elevator. And as you can see, even though we only had one batch of positive PED feed that was initially contaminated, that one batch allowed for a continuation of PED contamination in the environment. Again, more than likely, this was from this PED being attached to the dust, and shows the presence or the ability of this dust to be able to be maintained in the system, even though we don't have any PED being detected in the feed. And so again, the focus back on the dust, the focus on the equipment, the focus on the challenge of getting a feed mill decontaminated is a really big chore. And ultimately what that means is the importance of focusing on prevention, of being able to bring products into your feed mill that you know are low risk, or no risk, if there's such a thing as no risk. That's the goal of each of these feed mill systems. And so what we did right here then is not only did we want to know whether this feed was PED positive, but we wanted to know if it caused infectivity once we put it into pigs. And so here's the second portion of this study, where along my left axis are the treatments, the negative feed, the PED feed, and then the 4 sequences. And then we have the number of pigs that were become infected through 7 days post the initial inoculation. So really, a lot of numbers up here, but just to boil it down real quick, none of the pigs on the negative feed became PED infective, which is what we hoped. All of the pigs that received the PED infected feed became sick. For putting feed into pigs after the first sequence and after the second sequence, we still had a percentage of those pigs that develop PED infectivity, and so really demonstrates the clarity of the risk of cross-contamination in the feed manufacturing process to be able to transfer infectivity of this PED virus. What's really interesting about this is that the feed that we put into these pigs right here was obtained from the samples from the mixer. So if you remember from the previous slide, after sequence 2, there was no PED detected in that feed. However, we were still able to make pigs sick by putting what we would suggest is a PED negative batch of feed into these pigs. And so really shows the severity of PED, the small amount of PED that can contaminate pigs, that can lead to infectivity. The nice thing, though, that once we get to sequence 3 and sequence 4, we didn't observe any sort of infectivity with these pigs. However, you have to be really careful about this. With these bioassays, it's a few number of pigs, it's a small amount of a feed. We were definitely able to demonstrate that we reduced the risk of cross-contamination by sequencing 3 to 4 times. However, I don't think we can go and say that we eliminated the risk, because we know that there was still PED on the surfaces of that equipment that potentially could get into the next batch of feed and lead to infectivity down the road. We've also looked at designing trials, and we conducted a trial where we looked at flushing between batches of feed. And so really a flush is nothing more than putting a batch of an ingredient or a small batch of feed after a normal manufactured batch with the goal of eliminating all of the residual material within that feed manufacturing system. And so what we did right here is we used rice hulls as the flush for this trial. We used rice hulls, number one, because of the abrasiveness of the rice hulls. We figured that there would be the scratch factor, that we could potentially scratch on the edges of the surface of the equipment, but also the density of rice hulls allowed more surface contact within the insides of the feed manufacturing equipment to potentially contact more surfaces and remove some of that contamination. What we did is we had these rice hull flushes without any treatment. We treated them with a commercial formaldehyde. We also treated them with a 2% medium chain fatty acid mixture and a 10% medium chain fatty acid mixture. And Cassie's going to talk quite a bit more about these medium chain fatty acids. But as we go down through this chart, what it does is it shows the number of pigs that became infected with these flushing treatments in the flushing trial. Didn't have any of the pigs on the negative control that became infected, which we expected. However, the pigs that were contaminated or fed the flush after a positive batch of feed all became infected with the PED virus. Once we put this through the laboratory scale mixers, the pigs, about half the pigs from the untreated rice hulls flush that were fed this actual flush material became infected. One of the pigs out of the 6 that were fed the rice hulls flush that were treated with formaldehyde became infected, 2 of the 2% medium chain fatty acids, and none of the pigs that were fed the flush from the 10% treated medium chain fatty acids became infected. However, if we put then a subsequent batch of negative PED feed after the flush, we didn't lead to any infectivity, and showed the value of the flush treatments here to be able to remove the residual PED that was within the system and hopefully prevent then the subsequent infectivity from consuming that feed. With the 10% medium chain fatty acid treatment, we're also able to move those the treatments into a larger scale mixer bucket elevator system, very similar to a commercial feed mill, and very much similar to the treatments that we had right here in the mini mixers. Whether we gave the rice hulls flush to the pigs, whether we gave them the subsequent feed, when it came out of the mixer, we had no cross-contamination that was present, which led to no infectivity. However, when we go back and we gave some of the rice hull flushes out of the bucket elevator, we did have one of the pigs that became infected with the PED, none of the pigs from the subsequent batch of feed. So again, demonstrates the complexity of trying to clean out a bucket elevator within a commercial feed mill, and just the importance of making sure that we can do a good job with a feed mill biosecurity protocol and hopefully a prevention type of a strategy, but also shows the value that flushes and treated flushes could have an opportunity to minimize the risk of cross-contamination within a feed mill. I'm going to hand it back now to Cassie to talk a little bit about some of the intervention strategies that we can have in the feed mill.
All right, so we have learned quite a bit about PEDV and how PEDV actually acts very much like an ingredient in many of these cases, where we see a lot of the same things when we're trying to flush antibiotics from the system, or when we're following things for some of our, if we have a licensed feed mill that has category 2 type A drugs, or some of those different pieces. It's interesting to see how the virus acts very much like an ingredient. I think it's also interesting that we expect a number of other viruses or bacteria to act quite similarly. And so in these examples, we are using PEDV, but we have done quite a bit of research with Salmonella that shows and acts very similarly to this. And then we're doing benchtop trials currently and getting ready to gear up on some with some of the folks that will be visiting with you this afternoon about with using African swine fever and classical swine fever. And so as we think about that from a foreign animal disease perspective, I think these are good pieces of it. This is good information to start to employ currently, because 3 or 4 years ago we didn't have PEDV either. And so what are some of the things that we can be employing if this does make its way into our system? And that's really where the intervention perspective comes in. And we've previously shared with you that pelleting can also help to reduce our risk. We know many of these pathogens are heat sensitive, and so some type of time-temperature combination can lead to destruction of the virus and prevent infectivity. And what Roger's data shows here is that infectivity developed in diets that were only pelleted below 130 degrees Fahrenheit, which is obviously quite far below any of what our current pelleting parameters are. However, remember, that is 100% of the feed, 100% of the time. That means that if you have startup, if you have plugs on your way back down, that as soon as you manufacture some of that feed not at 130 degrees, it could be potentially infectious, as is any surface it touches, such as your pellet cooler and any of the conveyors or load-out equipment or trucks or onto the farm along the way. And so pelleting is certainly something that we can be employing to reduce our risk, but it's not going to prevent any contamination for feed that's not going to reach that parameter. And it also is a point-in-time mitigation strategy, meaning that at that point, as soon as it exits the pellet die, it's PEDV free, but there's nothing that protects it from getting cross-contaminated as soon as it hits that cooler or any of the other locations along the way before it's in front of a pig. And so that's really where we've been focusing our strategies currently. As we've shared with you previously, that obviously commercial formaldehyde and some of our medium chain fatty acid work is quite intriguing, both in complete diets and in spray-dried animal plasma. And we see a very consistent response that over time, we see that PEDV tends to self-mitigate. The virus degrades over time, which is expected, like most pathogens would, in something like a complete feed. And commercial formaldehyde is not shown to be quite as effective in complete diets, but our medium-chain fatty acids really are. But the opposite is true with spray-dried animal plasma. Within plasma itself, this is a substrate where the virus does not have the natural degradation that we would expect to see from some of the diets or in complete feed, and we're still not completely sure why that is, but it's been a very consistent response across all of our experiments. And likewise, commercial formaldehyde is much, much more effective in some of those ingredients than what we've seen in some of our complete feed diets. So that's kind of where we were, catching you up on where we were last year. But as Jason talked through some of these pieces, we see repeatedly now that medium-chain fatty acids, both in Salmonella and in PEDV, really have some type of efficacy, which surprised many of us. And so we started to dig into what are some of the antiviral properties of these fatty acids. And what we're really hypothesizing here is that the fatty acids themselves are binding with part of the cell membrane proteins. They're incorporated into the cell membrane, and what that does is it causes a destabilization of the lipid bilayer. And so as you see that, that gets pretty deep for some of us, but if it's a similar aspect regardless of what type of pathogen has a lipid bilayer. We would expect the same type of thing for Salmonella and many of our other viruses that we're potentially concerned about, that if we can replace some of those fatty acids, that they are potentially more susceptible to oxidation, and at that point we can start to degrade the virus. And there's a couple pieces that occur there. We certainly will see a drop in CT overall. We detect less of the virus, but we're still going to be detecting some because the viral fragments are still present. But unless it's in that whole sphere, it's not infectious. And so a typical response that we've seen from the medium-chain fatty acids and from some of our other feed additives is a little bit twofold. We'll see a decrease in overall detectability, or CT value, but we'll see a substantial difference in infectivity, meaning that the pigs can't get sick from it because the assay can pick up little fragments of the virus, but unless it's in its whole form, it can't actually make animals sick. And so we'll keep that in mind as we kind of go through some of the rest of the data that we've been doing over the past year. And we started to dig into, okay, what is it about these medium-chain fatty acids? Initially, we were testing a 2% inclusion level of a synthetic blend of C6, C8, and C10. Now, those are obtained from Sigma Aldrich. You know, some of the data is really exciting, but it is not something that pork producers, based on that data, could be incorporating on a widely basis. But the data was exciting enough for us that we started to dig into it, and so we're saying, okay, what is out there that we can start looking at that might have similar properties, or that we could maybe formulate that could be cost-effective into our diets? And so we ran this experiment. The black line is our positive control. The blue line is commercial formaldehyde, which again, that's a pretty typical response where you'll see a bit of a knockdown from formaldehyde in a complete diet, but not as much as our 1 or 2% medium chain fatty acid. Down at the bottom of the screen, you can see our bioassay results. And I really did it in this way, differently than a table, because my eyes start to go cross-eyed when I look at too much data. And so you can see that on day 0 in the complete feed, we had the positive feed make pigs sick. But by day 3, none of the diets were infective. By day 21, they still were non-infected. And so what that tells us is that within complete feed, there is some of this negative or some of this natural degradation, even in the black line, where if we're able to hold feed for a few days, we do potentially see some of this natural degradation, not as substantially, though, as what we would see with an inclusion of some type of medium chain. All right, so we looked at that as well in the medium chain fatty, or in spray-dried animal plasma, and as we saw previously, the MCFAs did not perform as well as what some of the commercial formaldehyde diets did, and that's very, very much reflected in the bioassay results as well. That by day 3, we still had infectivity of some of those diets, and by day 21, we still had one of the medium chain fatty acid diets that was infectious. All right, so along the way, the next set of trials was, okay, we're starting to see and starting to figure out that within complete diets, this 1%, we now have gone down from 2% to a 1% inclusion level of this blend of medium chain fatty acids. Now, which fatty acid is it? And what can we actually be using as pork producers to employ this? And so we started kind of pulling apart these medium chain fatty acids. And so one is a PEDV positive, so that's going to be the black line at the bottom. That was had the lowest CT value, or the highest quantity of viral RNA. And what we pulled apart here is that we got a great response from commercial formaldehyde in this experiment, our 1% blend, which we would expect. That's pretty typical of a response that we had seen. But we actually thought that we would see great responses from C10 and C12, so we fed them independently and together. Turns out we were wrong, as we are oftentimes in research, and it was actually the C6 and the C8 that were giving us our promising results. The other part of this trial is really evaluating, are there some things out there right now that could give us some of these similar responses? Is this really just fat in general that's able to replace some of these lipids in the membrane, or are there specific properties about medium chain fatty acids? And so we ran the same type of experiment with some natural fat sources, things that you can get out on the market now. And so we looked at, again, this is the PEDV versus the formaldehyde data, but you can see we tested choice white, soy oil, canola oil, palm kernel oil at a couple different doses, and coconut oil at a couple different doses, because those last two are the ones that we would think and show us have inherently higher medium chain fatty acid content compared to our traditional fat sources. Certainly not anything that's economical from a least cost formulation perspective, but if we're feeding high risk populations of pigs, it could be something that we could incorporate, and it's out on the market. But what we saw is obviously none of those natural fat sources were as strong as what commercial formaldehyde, or really provided any response compared to just the PEDV contaminated feed alone. And so that was a little bit disappointing, but then when we go to our bioassay, and so this is going to be evaluating the day 3 feed, okay? So it was inoculated on day 0, and we pulled samples on day 3 thinking, yeah, it's probably in a bin, and then gets in front of an animal, typically 1, 2, or 3 days after it's manufactured. And so we pulled samples off of day 3, and so our positive was positive. None of our cell curve medium chain fatty acid blend C6, C8, C10, or C10 showed infectivity. Then all of our natural sources did. However, the coconut oil pigs didn't break until day 7, showing that there is potentially something there that may be in coconut oil, because it does have the highest proportion of C6 and C8 of our natural sources, to help reduce some of the infectivity and reduce our risk for PEDV. And so I think that that's an interesting perspective, something that we're continuing to dig out about what are some of the sources that are out on the market now, and working with different companies to try to identify what we can utilize this information for out in the field. All right, the last part of this is what happens if our feed mill gets infected? What are some solutions that, we've gone through these different steps of biosecurity, and we still have some type of break, and we know that it came through the feed mill. And we've had a couple of producers that have come to us with this problem, and unfortunately there's limited solutions out there in the research right now. And so we have a grad student, Mary Mucky, who just defended her master's thesis, that really dug into this problem. And one of our key reasonings for this is that this is some of the swabs, those giant Q-tips that Jason talked about. After we were running one of these experiments in our feed mill, this is not the main feed mill, by the way, where we do lysine titration trials. This is our Feed Safety Research Center. And so after we had manufactured some feed, we took and we started swabbing and sampling different surfaces. Obviously, the surfaces that were what we call feed contact surfaces, the inside of the mixer, the inside of the bucket elevator, etc. But then we also started to swab other surfaces that were adjacent or even further away, and what we saw was gross contamination everywhere. And substantial contamination that as soon as we introduced PEDV into the feed mill, it went everywhere, and it went everywhere quickly, which is really a challenge for us because, it sounds easy. We can tell you control dust in a feed mill. I've been in plenty of feed mills. It's really hard to control dust in feed mills, right? And so what it took in order to reduce this is both synergize and bleach, and then finally a 24-hour to 48-hour heat cycle at 140 degrees. That was our option. Most of our feed mills can't do that, right? And so we started to look through what are some options that we have, and this is something that we didn't really have a great place to start with, and so we pulled some of the data from Ohio State where they were looking at trailer decontamination, and so we started to have these 4 by 4 inch surfaces that were different feed manufacturing surfaces, and we basically inoculated them with PED and tested different treatments to see if we can get the PEDV off of that surface. And we took swabs, this is an example of those swabs, and analyzed them for PCR. All right, what we showed, these are the different types of manufacturing surfaces that we tested. One was cement, one was plastic off of a plastic bucket elevator, one was rubber from a rubber belt of a bucket elevator, steel, and then a tote bag. And so what we showed, these are the inoculated but non-treated surfaces, is that some of these surfaces are much more challenging to decontaminate than others. And actually, when we look at this, rubber and steel were more challenging to decontaminate than what the tote bag or cement or plastic were, which was probably different than what we originally anticipated. But along the way, we started to test different treatments, and so along this, we have our positive control untreated rice hulls that were treated with the regulated level of a commercial formaldehyde, and then just straight formaldehyde, pipetted straight on the surface. Don't do that at home, folks. And then benzoic acid with a probiotic, a food-grade sanitizer, a hydrogen peroxide, Synergize, the quaternary product, and then bleach, sodium hypochlorite, and then our straight medium-chain fatty acid product. You can see similar results to what we had seen previously. We were hoping to find better solutions for you if this is what we have to do. But what this showed us both in steel and in cement is that if we have some type of contaminated feed mill, that means that we are tearing apart equipment, power washing it with Synergize or bleach or both, and then probably heating the feed mill in addition to that. It's not a fun situation. It's not something that feed mills were ever built or designed to do. And so as we think through those concepts of prevention and intervention strategies, we really, going into the winter months, really are trying to focus on those, because we have limited options if we do have a contaminated feed mill to get all of the viral and bacterial activity out of there and out of that facility through some of our current options. So with that, I'll turn it back to Jason.
Yeah, so the big takeaways here today, feed mills are a complex system, very hard to decontaminate, and ultimately all the solutions that we've talked about right here, none of them are 100% successful 100% of the time. So really what that means then is that we've got to place as many prevention interventions in the feed mills as economical and practical to be able to reduce and or eliminate contamination or cross-contamination. It all starts from the receiving procedures all the way through dust control, flushing, sequencing, pelleting, chemical additives as well too. The big takeaway also from that Cassie did a good job illustrating is just how tough it is to decontaminate a feed mill. And really, I think we can go out on a limb and say it's in essence impossible to decontaminate a feed mill right there. And so again, the focus back on the prevention, the focus back on some sort of intervention steps that you have in there to be able to eliminate the need to try and figure out how to get that mill decontaminated. Last thing I wanted to just leave you with is back to what Cassie mentioned as well too. Roger Cochran, one of our graduate students right here, put together this paper with some of our friends from PIC as well, and it does an excellent job of highlighting some of the initial thought process of designing a feed mill biosecurity plan. And so if it's something that you're interested in, you're looking at trying to figure out how to get started, this is an excellent resource to be able to utilize right there. And I'd encourage you to find this paper or contact us, and we can help source it for you as well too. And so